In processing the SSP-3D dataset, we found out that the silhouette provided by the dataset distributor was not accurate, so we changed the silhouette predictor from the so-called dense post to the SAM, which is segment anything model provided by Facebook, and we compare the final result between the two silhouette predictor, and then we can see from here. So the one predicted by SAM is more accurate. For example, there is a little triangular space in front of the elbow. But for the silhouette predicted by SSP-3D models like dense pose, it just merged into as part of the body. And also we can see, let's fast forward. But for SAM, it does have some problem because in using SAM you have to provide a prompt. It's like a clue for the SAM model to recognize which object does it need to predict. So the prompt we use is the key point of the person in the image, also the bounding box of the person. So sometimes the key points may lie outside of the clothes, so the clothes will not be recognized as part of the person. So in predicting the silhouette, SAM can accurately predict the person, but the clothes or the volleyball will be excluded. It do has benefit and also have some disadvantages. So it really depends on your task to decide whether you want a very accurate would you like the roughly accurate or very accurate with some occlusion of the clothes or the volleyball? So of course we can further improve the silhouette by changing our input prompts. Currently we use the 17 key points and the bounding box of the person. Okay, so we fast forward, we can see that of course sometimes the clothes will be occluded, but sometimes it will not. Really depends on the key points, where the key point lie in the image. Okay, let's fast forward. Let's see. We just want to make sure the binary silhouette predicted by SAM is is as good as the one provided by SSP-3D. Okay. Okay, generally speaking, yeah, it's more accurate, especially in terms of the contour. It's more fine-grained, but it does have problem of object occlusion, like the bar here, right? And of course, the clothes. Sometimes it will be occluded. Okay, but in general, it does provide a quite accurate binary silhouette of the person, and in the current setting, we just input all the key points we have, as long as the confidence of predicting the key points is larger than 0. So here, for example, here the the feet was occluded by this lifting weight. So the confidence of predicting the ankle key point may be low, but we use it as part of the prompt. But unfortunately, the key point location resides, coincide with the location of this weight. So the weight in this image become part of the person's body, which is not what we expected at first. So one thing we can do is that we can increase the threshold. We can set a threshold that if the key point is predicted lower than certain threshold, then we are not going to use it as part of the prompt feeding into the HMR model. Then maybe this problem can be resolved. Okay, but in general, the silhouette is quite accurate. Okay, right. Let's fast forward. Right. All right. So the problem here is again the occlusion of either object or closest. So you can change the prompt you used to circumvent these circumstances, and that's it.